Welcome to Environmental Education, Education for Rural Citizen, Teaching Module 5, Water Resources and Water Balance for Sustainable Communities. This presentation is about water balance, climate change effects, and water pollution. It's a case study of Rangárvellir in Iceland. Water balance is a crucial concept in hydrology and environmental science, representing the equilibrium between water inflows and outflows within a specific system. This balance is essential for sustaining natural ecosystems, supporting human activities, and ensuring water availability for various purposes. The complex interplay of precipitation, evaporation, runoff, infiltration, and other hydrological processes determines the state of the water balance in a given region. The world's freshwater resources are distributed across various spaces, including rivers, lakes, groundwaters, glaciers, and wetlands. These sources play a crucial role in supporting ecosystems, human communities, and economic activities. However, water scarcity and mismanagement are increasingly becoming a global challenge impacting billions of people. Despite the abundance of freshwater resources on a global scale, several regions face water scarcity due to uneven distribution, increasing demand, and unsustainable water management practices. Factors such as population growth, industrialization, climate change, and pollution further exacerbate water stress in many parts of the world. The water cycle, also known as the hydrological cycle, is a continuous and natural process that describes the circulation and transformation of water on Earth. The water cycle involves several interconnected stages where water transitions between different physical states as it moves through the atmosphere, land, and oceans. Climate change refers to the long-term alteration in the Earth's climate patterns, specifically changes in temperature, precipitation, and weather events. The primary driver for modern climate change is the rapid increase in greenhouse gas emissions resulting from human activities. Addressing climate change requires a collective global effort to reduce greenhouse gas emission, transition to renewable and sustainable energy sources, conserve forests and natural habitats, and implement adaptation measures to cope with unavoidable impacts. Climate change has significant impacts on the water balance of various regions around the world. Some of the key effects of climate change on water balance include changes in precipitation pattern, altered snow melting timing, increasing evaporation, glacier melting, sea level rise, groundwater depletion, water quality issues, and shifts in ecosystems. Water pollution refers to the contamination of water bodies such as rivers, lakes, oceans, groundwater, and even drinking water resources by harmful substances or pollutants. These pollutants can be natural or human-made, and they disrupt the normal functioning of aquatic ecosystems, endanger human health, and adversely affect various forms of life that depend on clean water. Water pollution disrupts aquatic ecosystems by harming aquatic plants, fish, and other organisms. It can lead to loss of biodiversity and the destruction of habitats. Water pollution can render drinking water unsafe, leading to waterborne diseases and health issues in human populations. Efforts to combat water pollution involve a combination of regulations, pollution control measures, and public awareness. Water pollution is a multi-phased problem that demands a collective effort from governments, industries, communities, and individuals. Iceland, known as the land of fire and ice, is a country abundant in water resources due to its unique geological and climatic characteristics. The country's water resources are mainly derived from its glaciers, rivers, groundwater, lakes, and geothermal hot springs. Iceland is home to numerous glaciers covering approximately 11% of its land. These massive ice formations act as natural reservoirs, storing vast amounts of fresh water. During the summer months, As the glaciers melt, they release meltwater into rivers and lakes, contributing to the country's water supply. Due to its abundant water resources, Iceland has harnessed its hydroelectric and geothermal potential for electricity generation and district heating. Hydropower and geothermal energy together account for almost all of Iceland's electricity production, making it one of the greenest energy systems in the world. This presentation will present the Hydro Resilience Project, which will assess the effect of ecosystem restoration on the resilience of water resources by increasing the field capacity in the Rangárvellir restoration area in southern Iceland. Rangárvellir is blessed with abundant water resources, including glacier-fed rivers, groundwater, and volcanic lakes, essential for the region's ecosystem and economic and energy production. Historic challenges such as dramatic deforestation during the last millennium and year-round livestock grazing, along with devastating ash emissions during volcanic eruptions and a harsh subpolar oceanic climate have led to severe degradation in Rangárvellir. Since the beginning of the 20th century, diverse restoration measures, including forestation, soil conservation, and wetland restorations have been implemented, restoring large part of the Rangárvellir area. These efforts secure water availability during droughts, reduce flood risk during heavy precipitation events, and enhance the water quality in some cases. In the Hydro Resilience Project, we will assess and quantify the evolution of water resources in Rangárvellir by assessing the runoff dynamics in the main rivers of Rangárvellir under 4 main scenarios: present condition, degrading conditions, as was the case 100 years ago, under hypothetically fully restored ecosystems, and finally, under conditions of a scenario developed in collaboration with local stakeholder groups to optimize socio-ecological benefits. For this purpose, existing data will be complemented with additional field observations. The dynamic of the relevant hydrological processes in the area will be reconstructed using hydrological models to run the above-mentioned scenarios. Based on the initial investigation, we hypothesize that restoration has a significant reduced flood peaks and increased groundwater availability during dry periods. These scientific findings and conclusion of this project will generate valuable insights on the effects of land restoration on water runoff and water quality. In summary, this presentation explores the significance of water resources, climate change, water balance, and water pollution, focusing on Iceland's Rangárvellir as a case study. It emphasizes the need for responsible water management, conservation, and pollution control, especially in the context of climate change. Thank you for your attention.